Hello dear friends. In previous video lectures we talked about the layout design and we learned about some approach for layout design. If you remember, when we compare alternative layouts with each other, one of the considerations is to calculate the score. And usually while calculating this score we use a cost of moving one unit item for one unit distance. This cost, the problem is, what is this cost? How can we estimate this cost? How do we know this cost? And is it the same for all moves or different between each moves? For example, if we move an item from department A to B, then the cost of this movement can be different than the movement of the item, a part, from department B to C. So in fact, this cost is very related with what kind of a material handling system, material handling equipment you are using. Also, after, for example, representing the layout as a block layout and finding the best alternative approach, then you need to come up with a detailed layout. Okay, so in block layout, usually we don't consider these aisles, corridors between the departments and etc. But we include an allowance for these, and after we come up with the final layout, we include those details into the layout. Then the problem is you need to know what kind of material handling systems or devices you are using so that you need to arrange those aisles between the departments, the entrances of the departments, and etc. All those things are important. Also, for example, we said that in the craft algorithm, we are calculating the distance between two departments from the centroid of one department to the centroid of the other one. But in fact, if you are using a one-way conveyor, loop conveyor in between these two departments, then the distance is totally different. From A to B, the distance can be different than B to A, and etc. So what I am trying to say is the layout design that the approach or the algorithms that we used in layout design are in fact very related with the material handling equipment and the material handling system. So therefore, it's important to learn what's material handling, what are the key principles of material handling, and what are the basic types of material handling equipment. So in this video lecture, we will learn about these material handling devices. So let's get started. As I tried to explain, the layout design and the material handling systems design are inseparable. They are integrated to each other. So for example, in your book, this chapter comes earlier than the layout design, but in our lectures we first covered the layout design and then we started material handling. So they are integrated. In fact, they are you cannot separate them from each other. So in order to design your overall facility, come up with your overall facility design, you need to consider the material handling. You cannot just ignore it. And the material handling arises in many different contexts. And for each one of these, there are a lot of alternative solutions, and you need to come up with the best solution. And the thing is, this best solution is also most probably not unique, but there are a number of more than one single best solution for material handling systems design. So it means that for a design, you can either use alternative A or alternative B, and these two alternatives for material handling perform equally well. They have their own advantage and disadvantage, and you cannot say that one is better than the other. So the situation is this, and there are a lot of alternative designs, material handling designs that you should consider. What is the importance of material handling? Can't we do without material handling? There are a lot of different studies in different sectors, in different companies, and in different countries in the world. And according to these, for example, we have some statistics saying that in a typical industrial facility, this material handling accounts for 25% of all employees. So assume all the employees working in the facility, working in the company, the sales people, production people, and etc. When we consider all of them as 100, so 25 of these employees usually or typically work for material handling. Also, the total space allocated for material handling is more than half of the factory space. This 55% includes the storage, the movement items, the equipment storage, the parts storage. Okay, so all these spaces accounts for 55% of the total factory space. And another important statistics is this: 87% of the production time of a part is spent in material handling. As I said, in different sectors, in different industries, these numbers may change, but it gives you an idea. Okay, so only if you look at this one, the value adding activity to a part is the machining operations, for example, assembling operations. And those machining and assembly operations account for only very small percentage of the total time. Okay, and the largest percentage is due to material handling. Here it says that the total cost of the manufactured product, if you consider this as 100, then again, depending on the part, depending on how you are producing it and etc., 15 to 70% of this total cost may be due to material handling. You see, in some cases, this material handling cost can go up to 70%. So the item that you are buying, okay, you are paying for that item, and that cost, 70% of that cost is only for moving and storing the item, not for machining, not for production, or not for the people who produce it. And what is the goal? The goal is totally eliminate material handling activities. If it is possible to produce the item without any material handling, that would be the perfect thing. But of course, there is no such production. Having these statistics, then we can see what we will obtain by improving our material handling system. So we can say that with such an improvement, we will have a more efficient manufacturing. We will have a more efficient distribution of flows. The requirements for the material handling equipment will be reduced. Total manufacturing cost will be reduced, and you will obtain a competitive advantage. Your cost of the part will be reduced, and you can sell the item cheaper. Your inventory levels will be lowered. Okay, so lowering inventory levels means lowering inventory costs, okay? And also the space you need for the inventories will also be lowered. And also with the improvements in material handling system, you will improve the safety. There are many cases or there are many in industry accidents related to material handling equipment or systems. So by improving the material handling system, you can improve the safety as well. Okay, after these statistics, let's start with the definition of a material handling. So when we say material handling, what do you understand? How can we define it? In fact, we can define it by using a number of rights. In fact, a large number of rights. Material handling means providing the right amount of the right material in the right condition, at the right place, at the right time, in the right position, in the right sequence, and for the right cost by the right methods. Okay, so you need to think about these, all these rights to figure out what's going on. For example, we are saying that the material handling means providing the right amount. Okay, you need to move a part from A to B. Okay, then what should be the right amount? If you move, for example, more than necessary, it means that those items need to wait in that department, which is a VIP inventory, and it will need space in that department, and it will increase your VIP costs. Okay, so for example, if you send less than necessary, then your production can stop due to lack of parts. Then moving the right material. If you move, for example, depending on your production plans, if you need to produce part A, but if you transfer part B, again you will need part A, the necessary part to continue with your production. If you start producing part B, then you change your production plans. Again, this reduces the efficiency of your system. Okay. In the right condition, again, for example, if these departments need some kind of heat treatment and etc., or if you are making some chemical processes, then after the chemical process in one machine or in one department, you need to move these parts to the other one in a certain amount of time so that it should be exposed to oxygen, to air, a certain amount of time. If you move it slowly, if you move it late, then the item will not be in the right condition, and maybe it will be a scrap. Okay, so at the right place, again, you need to place these items, the material, to the correct places in the departments so that the departmental operations are smooth. At the right time, if you move an item late, then the succeeding activities may be stopped due to lack of parts. If you move them early, then your VIP inventories and material handling costs or material handling times can be longer. Okay, in the right position. So again, for example, if you are if you are using a material handling device, for example, an industrial robot to load and unload the machines, if these materials are not placed in the right position in front of this robot, then maybe it will not be able to hold the part with its grippers. Then another operation is necessary to change the position of these parts. Also, for example, so these are just examples that I am giving. You can give many more examples. For example, if you are storing an item and if you do not store these items in a correct position, then again, because of the weights on top of them and etc., they may be failed, or they can be become scrap or poor quality items. So you need to move the parts in the right sequence, which depends on your production sequence and production plans. Okay, and you need to do this in the right cost, using the right equipment, using the right number of material handling operators or workers, okay, and using the right type of material handling device, either a conveyor or an AGV, by the right methods, again depending on what using the correct type of material handling device, whether a manual one or an automated one, so using the right methods. So we can say that the material handling is both an art and science, like the facilities planning, we talked about it, or we can say that operations research, mathematical modeling is also both art and science, and this is also both art and science. Okay? So you need to, material handling involves the movement, storage, control, and protection of goods and materials. Okay? So these are the important aspects related to material handling: movement, storage, control, and protection of goods and materials. And material handling is related throughout the manufacture, distribution, consumption, and disposal of the part. Okay, it is not just related with the in-factory logistics, in-factory things like manufacturing, but also after you produce the part, the distribution of the parts, the consumption of these, and then when the use of the part is finished, so the lifetime of the part is completed, then the disposal, collecting these parts and disposing them. Again, you need to consider material handling and logistics aspects of all these uh, operations. Then what are the objectives of material handling while, for example, designing a material handling system, while selecting the material handling equipment? What are we trying to achieve? So one objective is increasing efficiency of material flow. Okay? Efficiency of material flow. Another objective is to reduce material handling costs, improve facility utilization, improve safety and working conditions, facilitate the manufacturing process, increase productivity. The thing is, we want to achieve all these objectives at the same time, but sometimes it's not possible to achieve all of them at the same time with a single design. One design may reduce the material handling costs, for example, may minimize the material handling cost, but it's not as good as other alternatives in terms of safety and working conditions. Okay? So some of these objectives may be conflicting with each other. The thing is, you need to know about your system and which one of these is the most important, or are the most important ones for your facility. Okay? So you can put an hierarchy on these. Either you weight them, sometimes you can ignore some of them, but the thing is, of course, we want to achieve all of them at the same time. So usually, in order to solve this material handling design problem, it's often the case that there is no single mathematical model that can provide extensive solutions to this logistics or material handling systems design problem. And that's why these material handling principles are important in practice. because they provide these statements of the fundamentals of material handling practice. Okay, what is important, what you should concentrate on. They are coming from the experiences, from past experiences of material handling design, and they provide guidance and perspective to material handling designers. Okay, that's why these principles are important in practice. This College in Industry Council on Material Handling Education identified these 10 material handling principles. What are these? The planning principle, standardization principle, work principle, ergonomic principle, unit load, space utilization, system principle, automation, environmental principle, and life cycle cost principle. So these are the 10 principles that are recognized by this council. Okay. Now let's have a quick look at each one of these principles. The first one is the planning principle. So what's a plan? Plan is a prescribed course of action that is defined in advance of implementation. Before the implementation, you define this course of action. So that's your plan. So the planning principles, in fact, says that for material handling, you need to make this plan first. And while making this plan for material handling, you need to define the material. What are you going to transfer? And the moves. So when and where you are going to make this transfer. So together with this one, the method defines how and who. It means that who is going to make this transfer and how this transfer will be made. Okay, so before your material handling design, you need to make this plan, you need to answer these questions. The second principle is the standardization principle. So standardization means less variety and customization in the methods and equipment employed. Okay, we need less variety. So we need to standardize these material handling methods, also the equipment. So we need to reduce the variation in the methods that we apply, in the equipment that we use, and in the control and software that we are implementing, we are using. Okay, so we need to do this in order to achieve overall performance objectives. But reducing variety and standardizing these may reduce your flexibility, your modularity, and your throughput and anticipation for changing future requirements as well. Okay, so for example, in order to standardize your material handling equipment, you started using only forklifts, nothing else. But it means that if you have this, you can only carry items that are suitable for the forklifts. Is this what you want? Yes, reducing variation is important, standardizing is important, but the second part is also important. You shouldn't sacrifice from your flexibility, modularity, and etc. Okay. The third principle is the work principle. So how can we measure the work that we are making during this material handling? How can we compare, for example, alternative material handling systems with each other? How can we talk about the performance of our material handling system? And here, the measure of work in material handling is the flow, okay? The volume, weight, or count per unit time. How many items, how many times you transferred from department A to B. In total, how many cubic meters of items you moved, material you moved, okay? And this flow is multiplied by the distance moved, okay? This is just similar to, remember, distance-based scoring that Craft is using. Flow times the distance. The fourth principle is the ergonomic principle. And what's ergonomics? Ergonomics is, in fact, identifies the suitable conditions of work conditions for the employees, for the workers. Then it seeks to adapt work and working conditions to suit the abilities of the worker. And of course, the work that we are doing here is the material handling, moving the parts and storing the parts. So our material handling system should consider these ergonomic aspects of the work. The fifth principle is the unit load principle. It identifies a single entity that can be stored or moved, okay, at one time. So this unit load, if you are producing, for example, pencils in your facility, inside your facility, are you moving and storing these pencils one by one, or you are combining them into some kind of a container or tote or a cartoon, and then again combine these cartoons into a pallet, and so that you make all the movements with such a pallet or such a container. So within a pallet or a container, you have many number of items. So if you are making these moves with using such a standardized method, then the unit load is that. And in material handling, this unit load is very important. You should identify the unit load correctly and suitably, so that the decision on unit load may increase the total number of material handling moves and cost and etc. So this unit load principle considers this aspect of material handling. The sixth principle is the space utilization principle. So in the beginning we said that as a statistics, approximately 55% of the total factory space are due to material handling. So we need to pay special attention on space utilization. And in material handling, especially for example, in storing these items, you need to consider this as three-dimensional. Also, material handling equipment, depending on whether they are hoists or cranes or AGVs moving on the floor or moving at the ceiling of the factory, we should consider them as three-dimensional. Okay, and it's counted as cubic space. The seventh principle is the system principle. What is a system? A system is a collection of smaller parts, smaller entities. They are interacting with each other, but they are independent entities. They move, they make their operations, but their operations are affected and affected from others, and they also affect the others. So they are interacting with each other, and you need to work through a single objective. Okay, so a collection of these smaller parts is called a system. And we are talking about a material handling system. It's also a system. It consists of, again, smaller entities. So what are they? The equipment, or material handling equipment, material handling workers, also the material handling software that we are using, the storage system, okay, whether it's VIP or raw material or finished goods storage. All are these smaller parts, smaller aspects. And also, for example, material handling system between departments A and B. This is by itself a single entity, but it works through the together with the whole material handling system. Okay, so this material handling system design, while we are making this design, we need to consider all of these smaller entities, but we need to look at them from the top, consider them as a whole, and consider their total objective. Okay. The eighth principle is the automation principle. Automation in material handling is important and provides a lot of benefits, so that when you mechanize and automate these, you can increase operational efficiency, increase responsiveness, improve consistency and predictability. Also, they can increase the safety. For example, carrying very heavy items may not be very ergonomic for operators, but with such automated material handling devices, they are easier. But of course, while doing this, you need to consider the cost aspect, because such automated material handling devices are very expensive and requires a lot of initial investment. The ninth principle is the environmental principle. Of course, with the increase of environmental consciousness throughout the world and the rules and regulations that many countries and governments put into regulation, this environmental aspects became very important all over the world, and material handling system as one of the important parts that has the that uses a lot of resources in manufacturing. Also, you need to pay attention to these environmental aspects. Okay, so while selecting the material handling systems, equipment that you are using and making those designs, we need to consider their environmental impacts and their energy consumption. For example, you are going to select a forklift. So that forklift can be a battery operated forklift, or it can be a fuel or gas operated forklift. Which one will you select? So one aspect you can consider about how long will these items be operated, because if it is battery operated, then when the battery is exhausted, then you need to recharge it or replace the battery, and it may be time consuming. But if it's gas operated, then you can just fill in the tank and continue operation. But the thing is, okay, this is one aspect, it's important aspect, but on the other hand, which one consumes more energy? You should also consider this aspect in your as a selection criteria. So this environmental principle states that. The 10th principle is the life cycle cost principle. So what is life cycle cost? Life cycle cost is the cost that starts with, it includes all the cash flows, starting with the first money that you paid for this item during not the implementation. It starts with the planning, with the idea. Okay, so for research and development or planning this material handling systems, you start paying the money. So it's the first currency, and until you replace that material handling equipment, you place a new one. All the cash flow between these two time slots, time instance, are called life cycle costs. And while making your designs, you should consider all these costs, not only the operating costs in a certain period of time. If you just consider that, you may make a decision, but that decision may be wrong, because it may have this material handling system or equipment may have a large initial investment cost or large disposal cost, or its lifetime can be shorter That's why its impact on total cost may be higher. So in designing or improving material handling systems, there are too many factors you need to consider. And it's very easy, quite easy, to overlook these issues, especially the minor issues. But these minor issues can become major problems in the future. So in order not to overlook these, we may use checklists which are based on these material handling principles. And we can use these checklists to facilitate the identification of opportunities to improve existing material handling systems. We can ensure that everything has been accounted for, and it contains conditions where possible improvement opportunities may exist. So by using such checklists, we can facilitate the improvement of the current material handling system, or we can make a better design from scratch, again using such checklists. So let's see an example of such a checklist. This is an example checklist. So you see on this column here, we list the conditions indicating opportunities for improvement. So here, for example, the first one says that production equipment idle due to material shortage. Okay, so this is a problem that should be resolved. And if we observe this, then we put a tick here. And the thing is, how should we correct this? Again, here, these columns represent those improvement opportunities. In order to solve this problem, what do we need? Supervisor's attention. If that's necessary and that's enough, then we put a tick. If we need management attention, then we do this. If we need an analytical study so that we develop a better dispatching and scheduling method so that there will not be any material shortage, again we put a tick over here. If we need some capital investment, so we buy a new material handling equipment or new kind of a software and etc., then we put a tick here. And also if there are some other comments, we can fill in this one. So we have all possible opportunities for improvement here, and for each one of them we can put ticks for the corrective actions. So this is just an example of a checklist which is based on the principles of material handling, the 10 principles of material handling. Okay, so this is the end of this video lecture. We will continue our discussion on material handling systems in the following video lectures.